Hi everybody, we're going to do problems 3 and 4 now. So let's take a look at problem 3. It's a chi-square goodness of fit test. So what we need to do, we have the observed values and we have the probabilities, so we need to calculate the expected values. And we remember from the other day that the expected value in any particular category is n, the grand total n, times the probability of that particular category. So expected value in category 1 is n times probability in 1. So in this case it's going to be 145 times 0.25, and that's going to give me, hang on a second, 36.25. That's also going to be true in category 3 because I have the same probability. Now for category 2, I'm going to have 145 times 0.5, and that's going to give me 72.5. Alright, so those are my expected values. Now what I'm going to do is get the observed minus expected. Oh, there's my appointment schedule. Okay, so I'm going to have my observed minus expected, the quantity squared over expected for each category. So my chi-square star, my observed in the first category is 20, minus expected of 36.25, the quantity squared over 36.25, plus, I'm breaking this up into pieces, 90 minus 72.5 squared over 72.5 plus 35 minus 36.25, the quantity squared over 36.25. Okay, see where I'm getting the pieces from? It's observed minus expected in each category. Observed minus expected, the quantity squared in the numerator, divided by expected. Okay, start putting these together. So I'm going to have, hang on a second please, and your other movie loading up to YouTube even as we speak. So I'm going to have 20 minus the 36.25. I'm going to square that. And divide by the 36.25. And that gives me 7.28. So my first term is 7.28. My second term, I have 90 minus the 72.5. I square that and divide by the 72.5, and I get 4.22. And then the last term, I take 35 minus 36.25 and square it, and then divide by that value, and I get 0.0017. Let me double check that. I think it's right, but let's double check. Let's see, 35 minus 36.25, and square. So I get 1.5625 divided by that, 36.25. Good thing I checked. 0.043. So let's just make it 0.04. And let's add all these babies together. So I have 7.28 plus 4.22 plus 0.04, and goodness me, let's see, 7.28 plus 4.22 plus 0.04. How about 11.54? Does that sound good? Good. All right. So that's our test statistic, and we'll come back to that in a minute. All right. So now we need to set up our test of hypotheses. So essentially, when you set up the null, it's just going to be a listing of the probabilities. So you're going to have P1 is 0.25, P2 is 0.50, and P3 is 0.25. Again. Then H1 is at least one P sub I is incorrect. Okay, and your test statistic, of course, is your 11.54. All right, you need to look up chi-square at alpha with k minus 1 degrees of freedom. The k is the number of categories. In this case, there were 3. All right, so if you look in the story, the alpha was 0.01. There were 3 categories, so this is going to be 2. When I look up, and you can use R to do that, if you look up chi-square at 0.1 with 2 degrees of freedom, and remember to use the upper tail, you're going to get something like 9.21. Okay, and you have to put together an if-then statement. So your if-then is, this is 3 continued, if chi-square star is greater than 9.21, then we reject HO. So in this particular case, we reject HO. Something wrong with that theory there. Okay, good job. All right, let's go on to problem 4, the test of independence. Start out with a nice clean. And in this one, this is kind of interesting. Of course, I think it's interesting because it's left-handedness. And you're looking at men and women and left-handed and not left-handed. And roughly about 9% of the population is left-handed, for what it's worth. And here's just a little study that Scripps are the newspaper, or it used to be the newspaper people. I'm not sure if they're still around anymore. I stole this from an old book. And let's see what we can come up with. So when we have a test of independence, the numbers inside, not including the total row and total column, are your observed values. You need to calculate expected values. So expecteds in the test of independence, expected for a cell Ij are the row total for I, column total for j, over the grand total n. So E11 is equal to row total 1 times column total 1 over n. In this particular case, you're going to have 100 times 267 all over 300. So let's multiply that out and see what we get. 67 divided by 3. And we get 89. Oh gee, too bad, I was hoping for some more 666s. Okay, and as I mentioned today in class, we have to maintain row and column integrity. So once you've got that first square, everything else falls out by addition and subtraction. Then I know E12, since the first row has to add up to 100, then E12 must be 11. E21, let's see, has to be 267 minus 89. So let's see what that is. Let's put that in the old calculator. 267 minus 89. And that gives me 178. And then to get the last one, let's see if I can, there's a way I can push this up a little bit. Oh well, I'll just go to the next slide. There's a way you can okay, go ahead. There it goes. Okay, so it is 178. Can't remember how to do it. Okay, and then E22, you can get in one of two ways. You know that 11 plus something has to be 33, so you could take 33 minus 11 and get 22, or you can do it across the row, either one. Okay, so then you start putting together your chi-square stars. The only difference between this one and the previous one, you just have more items to do. Okay, so you're going to have 83 minus 89, the quantity squared, over 89, plus 17 minus 11, the quantity squared, over 11, plus, let's see, what was that last one? Let's see, 22. Let me go a slide back first. Okay, so you've got gender and hand dominance are independent. Gender and hand dominance are dependent. You've got your chi-square star of 5.51. You're going to get your chi-square star, your chi-square of alpha with k minus, sorry, my fault, with, well, with r minus 1 times c minus 1 degrees of freedom, and that's going to be 0.10 in this case and 1, and when you look that up, it's 2 point something. Hang on, I gotta switch back to the other computer. I forgot to write it down. Hang on. .706. .706. So your if then is going to be if chi-square star is greater than 2.706, then we reject HO. Reject HO. So we reject HO. And as I mentioned, this shows independence. Excuse me, I lied. I rejected HO. That is, they are dependent. I'm agreeing with H1. They are dependent. Okay? All right. I hope this helps, and I'll see you tomorrow.